Hello friends, welcome to our website automationcommunity.com. Today we are going to see another example which is control VFD using PLC and HMI. First of all, let us understand the problem definition. Here I have created one HMI screen from which user will enter desired RPM over here. After that, when user will click on this set RPM button, this RPM will be stored in PLC, and based on that it will give one output voltage which will be given to VFD, and VFD will run near about our set RPM. Besides that, here I have created some buttons like forward button. If the user will press this forward button, output Y0 will be on, which is connected to S1 terminal of VFD. So here I have used output indicator to show the status of S1 terminal of VFD. If forward button is pressed, this terminal will get supply and VFD will run in forward direction. Similarly, if the reverse button is pressed, you can see over here, it will on output Y1 which is connected to S2 terminal of VFD. And there is the stop button to stop the motor, and also to change direction from forward to reverse or vice versa, we have to stop the process. Here the value of D1 shows the data which is to be moved to analog output module in order to produce this output voltage. And now why this output voltage? Because to get this RPM we have to give this particularly voltage, and how we can know all this, that we will understand in further slides. Right now just understand that this is the value which PLC will write in analog output module in order to get this voltage, and this is the output voltage required to this RPM. Now let's move forward. In order to check our programming, we are going to use Yaskawa 8000 VFD simulator for this project. Its download, installation procedure and basic interface usage will be explained in the separate video. Video link will be provided in description. So this is how Yaskawa 8000 simulator looks like. Here you can see, to get this RPM, that is near about 1000, to get this much RPM we have to give this output voltage to VFD. That means output voltage from PLC to the input voltage to VFD. So you can see I have given same amount of voltage to analog input of VFD, and that VFD is running near to our set RPM. You can verify from here. Besides that, here the forward button is pressed, so S1 terminal is on. So we have manually on this S1 terminal, and so it is running in forward direction. So this is how we are going to check our programming. Now before moving ahead, let us understand the PLC and VFD wiring. So our main components will be HMI, VFD, PLC, analog output module and motor. We will give 3-phase power to VFD, and it has 3-phase output which will be connected to motor. There will be control wiring from VFD to PLC and a cable from HMI to PLC. Let us understand the wiring in detail. First of all, we have to give 24-volt supply to PLC and analog output module. Now there is no digital inputs because all the inputs will be taken from HMI screen only. Here you can see digital outputs. First of all, we will connect SN terminal of VFD user terminals to the common of our output. So this is the 24-volt supply from VFD. Now we will connect output Y0 to the S1 digital input of our VFD and output Y1 to the S2 terminal of VFD. So what will happen if Y0 is on? this 24 volt supply will flow from here to Y0 and from here to S1. And same for this, if Y1 is on, then power will flow from here and will be given to S2 terminal. Now we will understand the output of analog output module. So for that, first of all, we will prefer our manual of analog output module. This is the manual of DVP04DA. Here you can see for AC drive 0 to 10 volt output, we have to connect the V plus terminal and common terminal to drive. So same thing we have done over here. You can see we have connected common to the analog common of VFD and V plus to the analog input A1 terminal of VFD, and it is 0 to 10 volts output from here and 0 to 10 volt input to here. So this is all about the wiring. Let us understand logic required to write this programming. First of all, we have done some assumptions that our motor is 4-pole motor running on 50 Hz frequency. So its synchronous speed will be 1500 RPM. Now we will give 0 to 10 volt outputs from PLC to VFD. So first of all, if we give 10 volts to VFD, then VFD will run to full speed of 1500 RPM. But how we will get this 10 volt? So again we have to refer our manual of analog output module. Here you can see in the analog output range of the output module is 0 to 10 volt, and this can be given by writing 0 to 4000 in data register. That means if we write 4000 in the data register, output module will produce 10 volts. So VFD will run at 1500 RPM. Similarly, if we write 2000 in the data register, then output module will produce 5 volts and VFD will run in 750 RPM. So now we want to know what is the value required in data register for 1 RPM. So here we will do cross multiplication, that is, if for 1500 RPM we require 4000 in data register. So for 1 RPM, how many value should I write in data register? So we have done cross multiplication and we have get 2.67. So if I write this value in data register, our output will be 1 RPM. So now we will write a code in which what we will do, we will get RPM from user, then we will multiply that value 0.67, and the value we will get that we will store in data register, and based on the value of data register our output module will produce the voltages. So this is the logic. So let us understand in detail logic for each step in ladder programming. First of all, we will draw a latching circuit for output Y0 to run the motor in forward direction by using input X0 forward button and X2 stop button. Now this Y0 is connected to S1 terminal of VFD. Again, we will repeat this step for reverse. We will form latching circuit for output Y1 to reverse the motor by using X1 reverse button and X2 stop button, which is connected to S2 terminal of VFD. Now the main part, we will get RPM from user that will be stored in D0 register. Now when the set RPM button is pressed, this data will be scaled. That means it will be multiplied by this value, and then we have to move that data in D1 register. And finally we will write two instruction. This instruction is used to write data in analog output module. So we will write data of D1 in analog output channel 1. So as per the value in D1 register, output module will give output voltages. So this is all about our logic. Let us start doing programming. So friends, I am opening my as piece of software from here. Click on new file. Write name of your project. Click on OK button. So first of all, we will write device command list. So double click over it. X0 is our forward button. So I will just write forward over here. Then X1 is our reverse button. And X2 is our stop button. Now click on Y for outputs. Y0 is the S1. Y0 is connected to S1 terminal of VFD. So here I will write S1 terminal. And Y1 is connected to S2 terminal of VFD. Here we have used M0 as a set RPM button. So here I will write set RPM only. And we have used data register D0 to get RPM from user. So here also I will write set RPM. And D1 register is used to move data to analog IO module. So here I will write data to IO and close this. Now click on program button and right click over it and click on new button and click OK. So let us maximize this. First of all, write a network comment over here. So our first step was to make latching circuit for forward direction. Press enter. So for latching circuit, we need 3 contacts and 1 output. So first of all, select contacts. 1, then 1 in parallel and here 1 in series. Then 1 output coil. Now we will write address to each element. So this is our X0 forward button. We have to latch Y0 and we are using X2 stop button and our final output is also Y0. So here we will use the rising edge for start and for stop button we have to use NC. So this is the latching circuit for forward direction. Similarly, we will draw a latching circuit for reverse. So insert network from here. Write a network comment. Press enter. And the same network we will draw again. So and click output. Give its address. So this is our X1 reverse button. We have to latch output Y1 by using X2 stop button and again the output is Y1. Same here, we have to use rising edge and for stop button we have to use NC. So this is the programming for forward and reverse direction. Through PLC, X0 will be pressed and PLC will give Y0 output to VFD. So this is all about the forward and reverse programming. Now insert a network. Now we will write a network to store the RPM given by user. So here I will write move RPM to D1 register. Here we have to write set RPM. Press enter. So when the set RPM button is pressed, data given by user should be moved to D1 register. So first of all select the contact. Right over here M0. Click over here. Now we have to insert a move block. So go to functions. Select all type and right over here MOV. And this is the mnemonics for move function and click on insert button. So our move block is inserted. So here we have to write the source. Our source is D0 register and our destination is D1 register. Now you would be thinking where we have done the scaling. So as discussed in the logic, we have to multiply the RPM given by user to 2.67 and then store it to D1. So we haven't done any mathematical operation over here. So this thing we will do in HMI directly. So we won't do mathematical operation in ladder programming right now. We will do that in HMI only. So here it will be the converted data itself. That means scaled data, and this scaled data will be moved to D1 register. Now we have to write code for analog output module to get output voltage based on the value of D1 register. So for that, click over here, auxiliary design of extension modules. So this dialog box will be open. So first of all, select the 0 number. So this is the first analog IO module that we are connecting to our PLC. Now from here, we have to select our model. So as discussed in the presentation, we have used DVP04, digital to analog, as this module. So select this and click on setup button. So this is the analog output module. Now click on setup button. So this dialog box will open. So first of all, here you can see these are the number of control registers in the analog output module. First of all, what we want to do, initially here you can see output mode setting. Default it is 0 to 10 volt. If you want to change it, for example, you want the current output or you want to 1 to 10 output, then you can change the settings over here. But right now, we don't need to change because we want this output only. So no need to do anything over here. Now here you can see number 6 register is channel 1 output. So we have connected our output at channel 1. So select this. Now we have to write. This is the output module, so there is no read instruction only. Here there will be write instructions only. So select first of all the write instruction because we want to write data in analog output module. Now here it is asking for the condition when this write instruction should work. So this should work for all the time. So I will select M1000 because this is on every time. Now here we have to write what we want to move. So we have to move the data register. So select the D and here we will write data register 1. We want to move the value of D1. Now we want to move one data only. So now click on preview button so you can see the preview of our code. Now click on add to list and then click OK. But before that, let me explain you what is this instruction. LDM1000 means it will load contact like this, and then 2 means 2 instruction is going to work. Now K0 means, if you remember before, I have clicked on checkbox 0 number. That means this is the station number. K6 means the control register. Here you can see this is the number of control register. Here we have to write data. D1 means our source. This we want to move. And K1 means here you can see number of data. For example, if I click on 2 over here and then click on preview, so here you can see it is K2. Okay. Similarly, if I write D5 over here and click on preview, so here it will be D5. So this is the understanding of instruction. Right now, we don't want to do this. We will just move this instruction. That means D1 register in K6. That means channel 1 output. K1 means one data only. So click on OK button over here. Again OK over here. You can see our instruction is written. Again, let me explain you. This is our station number. This is our control register. That means output of channel 1. D1 means we have to move this data in analog output module. And 1 means one data only. So this is all about the programming of control VFD using PLC and HMI. Its simulation and HMI designing we will see in another lecture. If you want to learn more examples like this, show your interest by liking and subscribing our YouTube channel automationcommunity.com and instrumentools.com. Meet you in the another video.